Welcome to the project demonstration of IoT based battery monitoring and controlling system for EV system. So here EV vehicles we need to monitor the battery voltage levels and current levels continuously, and also we need to maintain the temperature of this battery pack should be normal always. So for this task we are making use of Arduino Uno, and for voltage and current monitoring purpose we are making use of two sensors which are used to measure the voltage and the current, and temperature of the battery pack continuously measured by this thermistor sensor. And based on these three values the system will control the voltage levels and current levels and uploading these values to the ThinkSpeak cloud platform for monitoring purpose. And coming to the controlling purpose, whenever the high temperature is occurred from this temperature sensor, then the system will on this coolant fan make the temperature of this battery pack should be low. So that is the purpose of this project, and continuously measuring the voltage, current levels and displaying on the LCD screen, along with upload the same data to the ThinkSpeak with help of this ESP8266 Wi-Fi module. And coming to the main components and power flow, so we are mounted this device inside a EV vehicle, and which will get the power supply from this battery pack only. This battery pack consists of 3.7 volts battery pack of 3000 mAh of milliamps per current can be provided from this battery pack, and these three are in series, so we will get 12 volt to 1 amp 12 volts 11.1 volt to 3000 mAh voltage and current will be output. So that is the input to the DC motor, which will representing as a EV vehicle DC motor, and the processing unit is Arduino Uno. And the next, this current and voltage sensor directly providing the input to this Arduino Uno board, and this is a switch to on of the motherboard, and this is a switch to on of this EV vehicle. And this one is a breadboard to distribute the 5 volts power supply to throughout the input and output modules. And this is a LCD display to show the status, and ESP8266 to upload the data to the ThinkSpeak. And this is a transistor board which will act as a switch to on and off this fan whenever the temperature crosses the threshold value. And here we have provided the charging circuits through this transformer, means to the grid we can charge this battery pack, as we are representing this as a EV vehicle battery pack. Right, the EV system can be recharged through this transformer just on the power supply to this one. So first of all we need to connect the battery at this B slots, and on the power supply to the transformer, there we can see the light indication which will show the status of battery is charging. So it will take 2 hours to be get fully charged. Till the duration we should keep the battery under charging, and after that you can disconnect this. So before demonstration, the first step is we should keep the battery under full charge for at least of 2 hours, and then this is a main on-off switch, is a power switch to on off the power supply to the system, and this is an on-off switch to power supply to this DC motor. Just we on this, there we can see the welcome message initially on this LCD, as well as next current and voltages will be displayed on the screen continuously. So here we can see the temperature is 28 degrees centigrade and voltage 11.61 volts, and current is 0. As of now there is no input to the DC motor. So when we on this, right, we can get the current rating over here. Right, actually before demonstration, before on the power supply to this cage, first of all we need to on the hotspot in your phone. So for that, go to hotspot settings of your phone, change the hotspot name to project 7157, and password should be 1234567889. After enabling the hotspot, and the AP band should be 2.4 GHz. After enabling these settings on the hotspot, and we can see the one device is connected. So after you enable the hotspots, then only on the power supply to the kit, then we can get the one device is connected. And next, coming to the ThinkSpeak, just log into the ThinkSpeak cloud platform from the given credentials. There we can see the channel called as data. There we can see the data is uploading to this one. So in the dot you can check the temperature and the voltages, voltages and the current. There's a field 2 is the voltage, field 1 is the temperature, and field 3 current. So we can get the live parameters. Before we can erase that, but before erasing that, go to data import export, means take a backup of this previously stored data, download that. So it will be downloaded in Excel sheet format, so you can open. By opening that, we can get the details of so-called date and time, and how many samples till now collected. And first one is, as we discussed, temperature, voltage and current details. Right, after we took the backup, now go to private view, channel settings, and in that only do delete channel, clear channel, clear channel. Don't do any other things, don't delete the channel, only clear the channel. And after clear the channel successfully, go to private view. There we can get the voltage, temperature, current. So previous data got erased. Now wait 10 to 15 seconds of duration. Means the system will take 10 to 15 seconds of duration to be uploaded the data to this ThinkSpeak cloud platform. You can see the light blinking on this one, ESP066. So now the data is uploading to this ThinkSpeak channel. Right. So you can see the data is got arrived. So 11.61 volts, and the temperature is 28, as well as this temperature, current is close to 0.5. So let it be. All right. And now coming to this temperature. So whenever we increase the temperature, let's use any external heater, there we can see the temperature rising. And when it crosses the threshold value, there we set the temperature threshold is 35 degrees centigrade. Then when it's crossed that, then automatically the fan got switched on. And once the temperature comes down to normal, 40 degrees we set the temperature limit. So when it comes to normal, then automatically it will get switched off. Once again we check that. So in this manner we are going to monitoring and controlling the EV battery system with the temperature and voltage current parameters monitoring.